This is part 3 of the sensorless FOC motor bring up chapter. In this video, we're going to run the motor in open loop using a line and go startup mechanism. The goal is to get the motor spinning smoothly and consistently before we ever try estimator based closed loop control. A line and go is 3 phases. It first aligns the rotor, next it ramps in open loop, then it holds at the open loop speed set point. Align and go is the startup state machine that runs before the sensorless estimation is trusted. It forces a known rotor angle, then ramps the electrical speed in open loop. Before we get started, make sure the motor is unloaded for this step. Our first objective is to achieve a smooth startup. Begin with the typical baseline settings shown here. In the FOC GUI, navigate to the Tuning tab, and then open the MPOS tab. We'll be focusing on the Align and Go section here at the bottom. The values shown here are the recommended initial settings. They are a solid starting point, but you may need to adjust them based on your specific motor. I'll walk through each of the Align and Go parameters, then I'll demonstrate using my bench setup. We first start with the align time. Set this to 1 second. This align time gives the rotor a moment to settle to the commanded electrical angle before the ramp begins. Next parameter is the ID ref open loop. For now, keep this as 0. Keeps the first spin simple. Next parameter is your iTotal ref open loop. This iTotal ref open loop is basically how hard we push an open loop. Start low and only increase until the motor starts reliably. Now we set the open loop speed ramp based on your application. The higher inertia systems need a slower ramp. Some examples are shown here. Drone motors are typically 50 to 70 Hertz, compressors at 20, and ceiling fans at 5. This ramp rate is how quickly the firmware advances the forced electrical angle. If the ramp is too aggressive for your inertia, the rotor can't keep up. You'll hear growling and you'll see higher current. Next, set the open loop speed set point to about 3% of your maximum electrical speed. This is intentionally low. We're choosing a speed that is easy to stabilize and repeat. We pick a low but stable open loop set point because the estimator needs the motor moving above a minimum speed before it can become reliable. This baseline speed is what makes the handoff possible in the next video. One very important note is to double check that the closed loop checkbox is not selected for this test. With closed loop unchecked, the firmware uses the commanded open loop electrical angle and ramp. It is not using the estimator angle yet. That's exactly what we want for establishing a baseline. Okay, now to recap some important notes for this open loop operation, we will start with low current and increase gradually until the motor spins smoothly. The align and go routine automatically positions the rotor before ramping up. And again, higher inertia systems require a lower speed ramp. Okay, so let's go back to the FOC GUI. Let's go to tuning and go to MPOS. For my setup, I'll be using the initial settings recommended. 1 second for the align time. Keep ID ref open loop as 0 amps. Let's do the iTotal ref. This is 20% of your maximum current. For mine, it was 8 amps for my max current, which gives us 1.6 amps. For the open loop speed ramp, I am using a drone motor, so I'll stick with 50. For the open loop speed set point, I'll do 3% of the maximum speed. My maximum speed was 880, which gives us 126 electrical hertz for the open loop speed set point. Again, make sure this is unchecked. Go ahead and write all parameters. From previous videos, you should already have your current controller parameters set up as well as your config parameters. We can go ahead and click start. Okay, so we do see the motor spinning, and for the first try it is spinning pretty smoothly. On the FOC GUI on the status window, you should see motor enabled FOC open loop speed ramp. Because I did set the open loop speed set point to 26 electrical hertz, it is showing over here as well as in RPM. You can also adjust the speed here. Let's go to 40. So now we can see the motor is spinning a little faster. Okay, so using the recommended initial settings, my bench setup was able to run the motor and spin smoothly and consistently. Here is a list of common open loop scenarios that you can follow. A key rule here is to adjust one variable at a time so you can get a clear feedback. When it's not smooth, change knobs in this order: the open loop ramp first, then current, then align time. Try to keep the changes small, adjust the ramp and currents in small steps, and do not exceed your app config peak current limit. If you're working with higher inertia systems like a fan or a compressor, expect to use slower ramps and sometimes a higher starting current. If you're working with drones or gimbal motors, they can typically tolerate faster ramps. Okay, so your tuning loop should be like this. If the motor doesn't start or it stalls, increase your open loop current slightly. If it's inconsistent across starts, increase your align time. If it vibrates or growls aggressively, that's usually the rotor losing sync with the forced electrical angle. Try slowing the ramp first, then reduce the current if needed. And more current doesn't always fix it. If the ramp is too fast, the extra current just makes the motor louder while still out of sync. If it still feels rough, reduce the set point and ramp, get it smooth at low speed, then work up gradually. If you trip faults immediately, try reducing the current first and confirm your maximum OC limits aren't too tight. So the goal is to get the motor starting smoothly, reach the open loop speed set point, and then repeat. We want to make sure we have 2 clean starts in a row with the same acceleration and no current spikes. Another thing too is to not touch this estimator settings just yet. If the open loop isn't smooth, the closed loop won't be either. We need to first fix the open loop baseline first. Once you have a repeatable open loop tune, you can go ahead and save your XML profile and call it open loop baseline. To save an XML motor profile, you will go to the top left, go to File, Save All Settings, and you can give it a good name such as open loop baseline. And you will click Save, and you can load this XML file again by going to the File, Load All Settings, and here we go. Once you load, you will click Write All Parameters. It will write all parameters and then it will turn green. And you can go ahead and start again. Okay, so that's part 3. Next video, we'll let the estimator provide the angle instead of forcing it. We'll bring up the estimator settings and then transition into closed loop torque mode.